This question is similar to question 14. I have described question 14 in details, so I'd like you to do question number 14 before you do question number 12. However, let's just go through it. We are told that an empty density bottle has a mass of 25 grams. Its mass is 50 grams when full of water and 45 grams when full of another liquid. What is the density of the liquid in kilograms per meters cubed? So again here, we are given the mass of an empty density bottle, and we are told it is 25 grams. We will call this mass M1. When the density bottle is full of water, the combined mass of the bottle itself and the water is 50 grams. Let's call this M2. And then when the density bottle is filled with another liquid, the combined mass of the bottle and the liquid is 45 grams. Again, we call this M3. From this information, we can calculate various physical quantities. But before we get started, we need to know what we are required to calculate from the question. We are required to calculate the density of the liquid. In order to calculate density of any substance, we need to know its mass and its volume. Volume is a space that a substance occupies. So in order to calculate the density of the liquid, we need to know the mass of a given sample of the liquid and the volume of that sample. For example, in this case, the density that we want is that of the liquid. So we need to get the mass of the liquid, ml, and then divide the mass of the liquid by the volume of the same liquid. It's simple to see how we can get the mass of this liquid. M3 is the mass of the bottle and the liquid. If we can subtract the mass of the bottle from this value, then we can get the mass of this liquid. So the mass of that liquid will be 45 grams, which is M3 minus M1. So 45 grams minus 25 grams. The challenge here is to get the volume of this liquid. How do we do that? Volume is the space occupied by matter. In this case, the volume of this liquid is the space that this liquid occupies in this bottle. I want you to get this picture, that the space that this liquid occupies inside the bottle is equal to the space of the bottle itself. If we can get the volume of the bottle itself, that is the volume of the space inside the bottle, we will comfortably be able to get the volume of the liquid. Now, how do we get the volume of the space inside this bottle? How do we get the volume of the bottle? We do this in a very simple way. In this second diagram, we've got the density bottle full of water, and we can get the mass of the water inside here. It's easy. We just need to subtract M1 from M2. So the mass of this water inside here is 50 minus 25. 50 minus 25, and we get 25 grams. This is the mass of the water inside the density bottle. That is the first step. Remember what we are looking for. Don't lose sight of that. We are looking for the internal volume of the density bottle, which we will equate to the volume of the liquid. And then it occurs to us that if we can get the volume of this water, it will be equal to the volume of the bottle itself. Now we have the mass of the water inside the density bottle. How can we combine mass of the water, density of the water, to get volume of the water? It's very simple. We remember that volume is equals to mass over density. The mass of the water inside the density bottle is 25 grams. The density of the water, we remember it is 1 gram per centimeters cubed. And this will be equal to 25 centimeters cubed. This is the volume of the water inside the density bottle. Therefore, the internal volume of the density bottle is also 25 centimeters cubed. That means any liquid which is put in this density bottle will have the same volume as the volume of the density bottle itself. And therefore, the volume of this liquid is 25 centimeters cubed. So we quickly come here and divide this one by 25 centimeters cubed. 45 minus 25 is 20 grams divided by 25 centimeters cubed, and this gives us 0.8 grams per centimeters cubed. Now, in order to convert grams per centimeters cubed into kilograms per meters cubed, we just need to multiply this value by 1000. And if we do that, it gives us 800 kilograms per meters cubed. So the density of the liquid is 800 kilograms per meters cubed.